Temperature remains the same during phase transition from solid to liquid state, therefore no change in kinetic energy. However, potential energy increases as bonds are broken during the phase transition, therefore delta U increases. Like gases, work done by an external force is positive when solid contracts. This is because the direction of the force and direction of displacement is the same during compression. For the same reason, work done is negative when the solid expands. Since work done is negative when solid expands, Q must be positive in order for delta U to be positive. When solid contracts, Q must be positive is W does not provide sufficient energy for delta U. However, Q can be 0 or negative if W is equal or larger than delta U. For example, ice can melt when a very high pressure is applied on the ice. The kinetic energies of molecules depend on the temperature. Therefore, there is no change in kinetic energy of the molecules when ice at 0 degrees Celsius changes to water at 0 degrees Celsius. The number of microscopic particles is proportional to the mass of a substance. For a fixed mass of 1 kg, the number of microscopic particles is fixed. In this case, the average potential and kinetic energies of these particles determines the internal energy of the substance. As given in the table, the potential energy of all the molecules in 1 kg of ice and water at 0 degrees Celsius is 0 joules and 3.36 times 10 to the power of 5 joules respectively. Latent heat of fusion is the amount of energy required to increase the potential energy such that ice can become water. Hence, the specific latent heat of fusion of ice is 3.36 times 10 to the power of 5 joules per kg. This is consistent with the change in internal energy for the 1 kg of ice. Work done by 1 kg of water, W is P delta V, and that is 1.69 times 10 to the power of 5 joules. The first law of thermodynamics increase in internal energy equal to Q plus W. So we get latent heat as 2.26 times 10 to the power of 6 joules per kg. There is little change in volume when the ice changes to water, but a large change in volume when water changes to steam. Thus, there is substantial work done when water changes to steam, meaning more heat input is needed for the work done required for expansion. The specific latent heat of vaporization of an object is therefore higher than the specific latent heat of fusion.